Hi guys, welcome to God Academy. In this lesson, we'll talk about the proof that square root of 2 is irrational. This is a step of testing for irrationality. In our previous lesson, we went through irrational numbers. We saw the conditions a number must satisfy in order to be an irrational number and some properties of irrational numbers. So let's go straight to this test. But before then, let's recap why and how, what should a number be for it to be irrational. So these questions can be answered in two ways. Number one, for a number to be irrational, then it means it cannot be expressed in the form p out of q, where q is not equal to 0. So any number that cannot be expressed in a fraction at its simplest form is said to be irrational. Then number two, the second condition, for a number to be irrational, then in its decimal representation, it should neither be terminating or recurring as seen in rational numbers. So these are the two major conditions that a number must satisfy in order to be an irrational number. On that note, how is square root of 2 to be tested as irrational number? If I have square root of 2, I will first assume that it is an irrational number. I'll first assume that it is a rational number. So I will equate square root of 2 to p out of q. Once I do this, the next thing is a simple algebraic expression. I'm going to square both sides of this equation. Then I'll have p out of q all squared. This gives me 2 is equal to p squared over q squared. At this point, I'll cross multiply and this will give me 2q squared is equal to p squared. So the inference from here is that if I have a number squared equals 2 times a number squared, then that number is said to be an even number. Yes, that is true. Let's see. If I have a number which is squared, so let's assume any number which is equal to 2 times another number is said to be an even number because the 2 here is an even number. So it means if the number is divisible by 2. Hence, therefore, we say P is even number. That is the first inference we make. If P is an even number, then I can replace P with any even number I can think about. Therefore, this is what I'll do. Let P be equal to a number 2k. So a random number, and this number is an even number. Why? Because I have attached 2 here. Once I know and I do this, the next thing is I will come and put this back to my equation. So let's make this equation, let's say equation 1. So I'll come straight and this is what I'll do. So putting this p equals 2k into equation 1, what do I do? I'll have 2k squared is equal to, wherever I see p, I'll replace p with 2k. So open brackets, 2k all squared. And this gives me 2q squared is equal to 4k squared. What do? I cancel through by 2. I cancel this and I cancel this. Hence, I'll have q squared to be equal to 2k squared. Now, what is the inference here? You can clearly see that q on its side is also an even number. So q is also an even number. Now, we've been able to define p and q that both of them are even numbers. And one of the conditions for a rational number is that it should be able to be expressed in ratio form p out of q, where both are in their simplest form. You shouldn't have two even numbers being a quotient whilst you've not cancel out the even, meaning there is a problem, and that makes square root of 2 becomes irrational, and is simply proved this way. See you in the next video. Don't forget to subscribe and follow this course closely. See you.